since I know we have a packed program today with a lot of information there that we're excited to share, I think I'm just going to move forward since it is 3 o'clock. I know we have people kind of chiming in. But without further ado, I'm going to get started here. So first off, I just want to introduce myself. My name is Kelly Scott, Director of the Farm Robotics Challenge, as well as Corporate and Foundation Relations for UC Ag and Natural Resources. So before we kind of get into the nitty gritty of everything that's happening with the Farm Robotics Challenge, just want to give you the lay of the land here in terms of expectations for today's session. So first, we're going to spend 10 or 15 minutes going over just an overview of the challenge and the rules and guidelines and how to get involved and what that looks like. And then I'm going to hand it over to our team from Farm-NG, who's going to do a presentation on the Amiga robot and its capabilities and how it can be used in the challenge. And then after we do that, we're going to head over to my colleague Sean Hogan at IGIS. That's going to talk about the addition of drones to the competition this year. And then we'll hopefully leave, let's say 5 or 10 minutes at the very end of the presentation to do some Q&A. As much as we try and think about all the questions that you're going to ask, there's inevitably something that comes up that we haven't addressed. So since you are tuning in, we want to give you the opportunity to have a few minutes. And if you think of something throughout the presentation, please just go ahead, pop it in the Q&A. I have my colleague Lucy Kahir on board here. She's going to be monitoring that. And if she thinks it's real vital that we answer that question right away, she'll pop it in to the conversation and flow. Otherwise, we'll just address it at the end of the session. So with that being said, just want to say welcome. Thank you for joining us today. If you're tuning in live, this is also being recorded so that we can post it on our website for anyone else who can't make the session to be able to view today. So kicking things off, we want to provide you an overview of who's behind this event and what the different roles are. So the challenge is hosted by UC Ag and Natural Resources, or UCANR, the acronym that we use. And we are the extension arm of the UC system. We have researchers, many of whom are called farm advisors, that work in essentially every county of California. And they work directly with our growers on issues in their local communities. So they're not based on a campus, they're living, working in the communities that they serve. And we're closely tied to 5 of the UC campuses. That's UC Davis, UC Berkeley, UC Riverside, Merced, and Santa Cruz. And the professors that are campus-based work on wider statewide issues that have to do with food production and safety and protection of our natural resources. So that's kind of the overview of UCANR. Our co-host here is AIFS, which is the AI Institute for Next Generation Food Systems. And this is a really cool multi-university research collaboration to advance AI for the food and ag industries. AIFS brings together more than 40 researchers from 6 institutions. We have UC Davis again, UC Berkeley, Cornell University, University of Illinois Urbana-Champaign, folks from UCANR as well as USDA ARS service. So the goal of AIFS is to accelerate the development and commercialization of novel AI-based solutions in food and agriculture. And they're doing this through multidisciplinary science, industry engagement, and workforce development, which is a big part of this program and what we're doing here. And then we have our technology partners. Farm-NG is on board, and they are leading ag tech company based in California in Watsonville, right next to Santa Cruz area. And they provide the robot platform for the competition, which is the Amiga robot that you saw there on the first slide. And then also this year, we've added UCANR's Informatics and GIS Services program. They're a resource for geospatial tools, knowledge and innovation, really a focus on applied research and cutting edge technology. Today, we'll hear about the use of drones for data collection, mapping and analysis. So kind of digging into this slide here, it gets down to the why and the so what. That's the heart of this competition. We're currently experiencing a wave of innovation in agriculture, driven by pressures in the marketplace as well as kind of environmental challenges. And that can be addressed with advancements in technology. So in response to those conditions that we're facing, we aim to create a competition that brings together our leading researchers, our bright young minds to apply their skills and talents to help farmers solve problems. So as a result, we hope this activity serves two big functions. One, to inspire students to pursue careers in agriculture, and then also help farmers solve on-farm problems using the new tools that are being developed in robotics that utilize AI capabilities and have the ability to also function autonomously. So kind of the overarching mega goal is, being able to support the advancement of the food system, solving challenges faced in crop production and crop and food production. So if that's something that you're hearing that really resonates with you, then you are definitely in the right space here. So in terms of the challenge, here's the prompt to get the gears turning. And it's simply, how can we use technology to solve on-farm problems? And rather than give you very specific details on what problem we would like you to solve, this competition is a little bit more open-ended. So a big part of this is that we're hosting teams from many different parts of the world. In fact, on this call, the people that registered are as far away as Austria and the Netherlands. I think we had some UK folks and some folks for Canada. So that's something new this year, that this is kind of spreading beyond the United States. And we're excited to get definitely other universities from around the world involved in this competition. So that being said, everyone has different climates, different crops that are grown in different regions, and really kind of unique aspects based on where they're located. So taking the starting point, really, number one here is to identify the problem by making a connection to a local ag partner. And who can you talk to that understands the day-to-day operations of farming, that person that is constantly troubleshooting, problem solving day in and day out in terms of solving problems to produce and grow food. Depending on the size of the farm, it could be the farm owner, perhaps it's a manager or director. Either way, it's beneficial if this person is also highly attuned to the economic realities of their business. And I've heard this used recently as being called farmer-focused innovation. So that's really what we're focusing on here. And I just want to take a minute to say that, because I know that many universities also have student farms that they work with. And while those can be great resources for field testing, for prototyping, for certainly ease of access to use, I think it's also important to connect to an ag partner that is active in the global marketplace. It's a real advantage in terms of getting valuable guidance and feedback on the commercial viability of your solution. So who are some potential ag partners? I mentioned before, it could be a farm owner, farm manager, a director, could even be an equipment manufacturer that services farms. It could also be a cooperative extension farm advisor or specialist, someone who works directly with the farmers in your area, as well as potentially a professor at your school that is highly involved and interfaces with the ag industry quite a bit. So for this presentation, we're really going to focus on elements 1 and 2 here. Farm&G and IGIS are going to talk a little bit more about technology solution, but the rest of the process is obviously putting together your design, building something innovative, and going through the exercise of field testing that, getting some data points and metrics to evaluate, and then presenting your solution to us at the end so that we can judge and present awards to the winning teams. So that's kind of the overall process of this whole challenge. So identifying the problem is where you need to start. Who can you talk to that either has the information that you're seeking or can help connect you to the right person? If there's students on this call, I would say definitely connect to your professors, the faculty members. If you're just in the process of forming a team, you're going to need an advisor anyways. So it's definitely work it to make those connections and get their buy-in support for what you're doing. If you're a professor and maybe you don't work in ag, maybe you're robotics or computer science, but you want to be involved, you can also reach out to this extension network. And I'm speaking for the United States here. Every single state has a land grant institution that houses a cooperative extension program that employs researchers in your local areas that support agriculture. And these are the people that are highly attuned and engaged with the farmers in your region. You can reach out to them about your project, get their feedback. They probably had a good idea of which farmers would be open to collaborating on a project that are kind of on the cutting edge of innovation and willing to take some risks. And there's a website here, extension.org. This website lists all the cooperative extension offices throughout the United States. So if you don't know who to contact, it's a really great resource to jump on, and it's going to lead you to the people that you're going to be able to link up with. Another entity that could be really valuable is a commodity group or a research consortium. And these are groups that represent certain crops. So in fact, we have two that currently sponsor the competition: the California Tomato Research Institute and the United Soybean Board. And either would be thrilled if you reached out to them and said you'd like to explore the possibility of doing a project with their growers. They'll gladly connect you and kind of guide you to the right people. And then I think ultimately it would be great to get down to the individual farmer that you can consult and partner with and really get some direct feedback based on their experiences in the field. So what does a farm robotics team look like? It starts with a team advisor. That's typically going to be a professor, a researcher, maybe it's a staff member. Some instances, a graduate student has filled this role in the past. It's basically someone that's identified as the team lead, that's responsible for things, that can be the primary point of contact that we as administrators communicate with in terms of updates and deadlines and getting things going. And then from there, team members. So team size is open-ended. Based on what we've seen in the past 2 years, there really hasn't been a team that's smaller than 4 or 5 students. And we've had the larger teams that are up to 20 to 30, kind of being on the high end, which you see here in this picture. Definitely an advantage to have a mix of students in terms of their majors and their skill sets. You're looking at every flavor of engineer that you can think of, computer science majors, data science, robotics, students in the ag and plant sciences field, but even business majors can participate in this. And I'll say, in terms of kind of the final product that you submit, part of which is a video, I think it could also be valuable to have a design or maybe a digital media student who can help kind of bring that all together to really make your presentation shine for the judges. So that's something to think about as well. We know all these students are readily available at your universities. So kind of rounding out the team, we talked a little bit about this earlier, is that kind of that mentor network. These are your ag partners. It might be an industry representative that specializes in a certain feature or product that you're incorporating into your design. Maybe someone looking at outside your university universe that can provide additional guidance on the project that you're working on. And then in terms of kind of getting going and registering, we'd like to know if you intend to compete by mid-December. And while we're not going to exclude you if you come in after that date, just in terms of history with the challenge, it shows that the successful teams pace out their projects over time versus coming in at the last minute and kind of trying to throw it all together at the end. So that date is really more to help you get organized on your end. But if you're going to come in later than that, we'll certainly allow you to participate in the competition. And so moving on to the fun part now, this year we have 2 separate categories that teams can kind of coalesce around and participate in. It kind of comes down to which tool that you'd like to employ to tackle the problem that you identified in step 1. So on the left here, we have the Amiga robot, which is the required platform for the land category, what we've dubbed land. You'll hear more about the Amiga shortly, directly from the FarmNG team that's on the call. The Amiga has been the platform for the first 2 years of the competition. We have many examples on our website via the different highlight videos that we have that you can check out and get some ideas going. If you haven't participated in the competition before, just go to our results tab and you'll have a lot of information that you can check out there. And then on the air side, this is new. We've added a category for teams that would like to work with a drone. So if you choose this one, you're going to be our guinea pigs this year for this category. And we're going to hear from my colleague, Sean Hogan, in a little bit. And he's going to give you some guidelines in terms of what equipment selection looks like, as well as what types of projects might come out of this category. So definitely stay tuned for that. And I suppose if you're really ambitious, you could try and integrate both and give our judges a hard time. So here's the challenge timeline for this year. Currently, we're in that team formation, kind of problem identification phase of the competition. Like I said, we hope to get majority of the teams to submit their application or intent to compete by mid-December, kind of before those holidays come, and we're on to different things for a few weeks. And then once we have a good idea of our competing cohort of teams, we're going to start programming some check-in dates to bring everybody together on monthly webinars starting in mid-January. We haven't selected the date yet, but that's what I'd really like to shoot for. And we can go over expectations on our first meeting in January for your project proposal, and we'll provide examples and kind of walk you through the steps of exactly what you're looking for, or what we're looking for, so that you can get that completed and in as kind of one of the first deliverable for the competition. Once you have your team formed and identified your problem, it's kind of fair game to start prototyping and testing your design. This work is kind of up to you. You can get going when you're ready. So that's why it's identified as ongoing on the timeline. And then towards the end of April, we're going to ask you and need you to turn in your final reports and video submissions so that we can get the projects over to our judging panel. And our judging panel is comprised of a mix of both academics and industry folks that are really interested in innovation and agriculture. And we also use this time to pull things together for our award ceremony. We have a cohort video that we like to produce that gives each project a little spotlight, and we show that during the award ceremony, and then we also have that archived on our website, so it kind of has permanence with the competition that teams participated. And I think that's a really nice touch. And then finally, kind of the aim is to hit that award ceremony. May 8th is what we're shooting for. It's going to be a virtual event, and hopefully we're getting this in before finals and students take off for summer vacation and on to internships and other things that they're working on. I'll just add, next year we'll aim to kick things off potentially a few months earlier in the year so that we really have true alignment with the full academic year in terms of the challenge, but that's what it's looking like this year. And I mentioned this several times, but let's just kind of dig in and outline what we're looking for. So the first thing is a project proposal document. This is a 1 to 2 page overview of your project. It will include information on your ag partner, your defined problem statement, a high level overview of your design plans, and several ways that you've chosen to measure your success and outcomes. And we have a step-by-step guide that's going to lead you through this. It'll be posted up on our website shortly in the resources section with the exact requirements. The next thing is the final report. This is what's submitted for our judges for evaluation. We have a judging rubric that we're going to provide you so that you know exactly what to expect, what sections have what scores and what order we'd like things. So just follow the plan and you'll do a great job on the report. And then lastly, 5-minute video kind of showing your project in action. As a virtual competition is a really important piece to showcase your work to our judges, the competition. It's also fun for the other teams that are competing to see what everyone else has worked on. And I'll say this piece could actually be really valuable in helping expose your project to a wider audience, which if you're interested in commercialization and building a business and going down that path, could be potential partners for you in the future. So in order to fuel this competition, we've set some stakes. Last year, the top prize winning team was awarded $10,000. I'm happy to say that we will match or asterisk exceed that this year. And a special shout out to Farm G for their support in putting forth what we're calling the Innovation Award for the land category this year to get that started. And then on the air side, we'll also likely match that $10,000 level as a top prize. And in addition, we're going to have a series of, we'll call them Judges' Choice Awards at this point, really to pick the projects that excelled in certain areas and highlight them as winners as well. Last year, a couple of the categories were productivity, sustainability, and small farms tech. And then we'll provide more information to the cohort as we kind of work and solidify these plans that we're working on. And then another thing that's important to us is kind of building this community. And as we're aiming to have the competition wrapped up in May, we want to offer our winning teams travel stipends to attend the FIRA AgTech conference. And FIRA really is kind of the epicenter of the ag tech world in North America. It's really a great opportunity for students and faculty members to get exposed and connected to the ag tech ecosystem and the myriad of startups that participate in this event. You're seeing, I think it's Stout here in front of their machine. And what's really great at the FIRA conference is there's live demos of the technology, and our farm robotics teams have a chance to be right next to these companies demoing their projects, which I think is really cool. It's highly motivating for them and a great opportunity for career development and networking. And kind of going back to this slide, lastly, I talked about building community. We want to continue folks down the pathway of success and developing your innovations. So if your project shows good commercial potential and we can connect you to folks that are going to help you down that journey. One of the programs here at ANR is called The Vine. It can assist with business coaching, networking, and exposing your ideas to investors and collaborators. So that's all part of this plan too. So I went over by 5 minutes, so I apologize to my colleagues. But just want to say thank you a ton for tuning in, for learning more about the challenge. Pop those questions in the Q&A if you have them. And there's my contact information up on the screen if you want to get a hold of me. Happy to have further conversation. And at this point, I want to hand it over to Leanne with Farm G. So I'm going to stop my share, Leanne, and let you go for it. Can you share your screen, Leanne? And you're muted.
There we go. Can you hear me and can you see Meet the Amiga?
We can hear you. We cannot see them, Miga.
Oh,
Hold on, I think you're spotlighted, and that might be why. I'm gonna spotlight Leanne. Can you see your screen now?
I see her screen. I see the Amiga.
okay, great.
Okay, great. I see it too, so.
Hi, everybody. So great to be with you today. I'm Leanne Gluck, and I head up education innovation at FarmNG, and I'm also here with Marcelo, my colleague who leads customer support. So welcome to the challenge and Meet the Amiga. The Amiga is a modular electric autonomous micro tractor that's configurable and open source. And so by modular, it can change the XYZ axis, so you can make it larger or taller. It has the capabilities to have, it has a 3-point and hitch, so it has capabilities to have multiple attachments come on top of it. So it can be a weeder, a seeder, a compost tea sprayer, a compost spreader. And those attachments can either be attachments that are off the shelf or ones that are created and customized by you. It also has GPS and cameras, so it can see and it knows where it is. And it has a brain and a software and OpenADK, so you can make it intelligent. You can make whatever you put on top of it intelligent. And we'll talk a little bit more about what that means. But it really is a tool to accelerate new capabilities and new innovations because it does some of the pre-work for you. It's got mobility, it has some autonomous features, and it's got intelligence. So it's kind of ready-made to build on top of. So this is just a example of some of the things that other schools and other customers have put on top of their Amiga. You'll see in the corner, Jacobs Del Cabo has a compost spreading machine that helps to create efficiencies in compost spreading. There's applications for pest management, for data collection and phenotyping, for weeding, for crop sampling, for precision spraying. So going back to what Kelly shared about problems that farmers are facing, it really is around thinking about what is the problem that you would like to solve, and then how can you leverage technology in order to support solving those problems. So I'm going to turn it over to Marcelo to talk a little bit more about our open source platform, our media development kit, and some of the opportunities for support that we have here at FarmNG.
All right, so I'll turn it from here real quick. As a good support guy, I'm going to refer to our docs, right? I want to talk first about what you get right out of the box when you have a new Amiga delivered, and then a little bit of on the software side, right? Basically, I'm gonna share some of the screen. So what you have, like with our the brain that comes with your Amiga, with your Farm Robotics Challenge kit, is basically a very rugged Jetson board, and that can stay outside. Our machines here, they stay in the field. They go overnight. So it's a package that is ready for the farm. With that, that's so basically that's a Jetson Xavier NX platform with a Linux operational system, but on top of that, we have what we call our FarmNG operational system, and basically it comes with some very basic functionalities like connecting to Wi-Fi, connecting to a GPS service and stuff like that, and then functionalities like if you want to record some of the cameras and things like that. But I suspect that you are interested on the development capabilities. And what you get there, I would say the first place, you're more than welcome to come to amiga.farmng.com to actually look for yourself. What are the resources available for you? But I would say the most important thing is that if you come here to developers and fundamental concepts, what you get with the Amiga is a bunch of services that gives you the capability of developing your project ideas without having to worry about hardware, right? So, for example, let's say that you want to build you want to build a GPS navigation project. So you have a GPS service that basically streams to your you can use it out of the box, all the latitude and longitudes that are being streamed to your application. You don't want a GPS, you want to use vision only. You have the Oak service, which basically streams the images from the cameras, and then you can do you can install models on these cameras and use them to do you can use models on these cameras and you can stream the services, the inference of those, right? And then we provide some other things like the Canvas service that provides odometry from your wheels. So the speed, RPMs, current, temperature from your motors. You have a filter service that provides a fusion of all the sensors, so you don't have to code this for yourself. You have a service that basically gives you track following functionalities from GPS track that you can build, and even some system monitor, so you can say, okay, my machine is using too many resources and things like that, so you can incorporate that. Everything on top of that, right? So we give you a lot of examples. Basically, last time I counted was like more than 35 examples on how to use all the services. So let's say, maybe I want to see how my GPS works. So you have a very extensive explanation here how to use, and all of these are hosted in our open source libraries here. So for example, let's say that GPS one that I just mentioned, you can come in here, GPS client, and you can see the code right there. So basically this is teaching you. So the idea is that when you come up with a project, you can come in here, okay, so these are the way, and you can start putting together these different services to build your application, right? And I guess the next step here is support, right? So how can we help you succeed in your project? And that's I guess that's an area that is near and dear to my heart, right? So I am with the support team here at FarmNG, and like I showed, I guess the first part is Amiga documentation. So, like I said, more than 30 examples, and then we have a lot of fundamental content there. Oh, how does the services work, right? So how you build your own services, how you interact those. So I think that's the very first thing, the very first place to look at. The second would be we have an open discourse community. Both like me and the other engineers here in FarmNG, we check that constantly. I check it at least twice a day. The good thing there is that you can share ideas and contribute with your peers. Then we will host open office hours. I think the frequency here will depend on attendance, but and then finally we have support at farmng.com. That's an email that comes directly to us. I route this to our engineers. I think we have Guy on the call. He's one of our software engineers. He's also an alum of the Farm Robotics Challenge. So we are here, we're here for you guys, and we really want you to succeed on this. So.
Kelly wanted us to talk just a little bit about some ideas around how to reinvent agriculture with AI and robotics. And really what we're excited about is, your innovative solutions for real world problems. And also, how can you use AI and robotics to rethink farming and agricultural systems and practices? And we've had a number of conversations with partners and farmers, organizations like the Nature Conservancy, different farmer partners around different kinds of challenges that they're facing. For example, we had conversations with the Nature Conservancy around farmers being interested in new ways to interplant corn. There's not current technology to be able to do that at scale, but with a lightweight autonomous micro-tractor, you may have the capabilities to do those things. A lot of farm technology right now is really built for monocropping, for planting one crop at a time. What does it look like if you wanted to support multiple crop species in a single field? What are the opportunities and challenges around supporting soil health and maintaining soil integrity while increasing productivity? There's opportunities to scale regenerative farming. The most recent winner of the Farm Robotics Challenge, and we'll show you a little tiny clip of that, was Olin. And they looked at building applications for weed control on top of the robot. There's farmers like Braga Fresh. I just had a conversation with Piscinus Ranch around the needs for eco-friendly pest and bug control. I talked to a farmer who said, our biggest problem in our orchards is actually the rodents. And how do we figure out how to support how to take care of the rodents? There's a farmer, big farmer, Braga Fresh, that are, doing 70 plus acres of regenerative farming and now looking at issues around other different kinds of pests and how to manage that. And again, looking at multitask machines and new technology for more complex management practices. And this can include, the way that the machine navigates. It can include, we have OAK-D cameras, for example, on top of our Amiga, but what would it look like to put hyperspectral cameras on top of the Amiga? What would it look like to put a soil sensor on top of the Amiga? It really is designed for you to think about the challenges that you guys want to solve in collaboration with the farmers or the industry partners that have those challenges. And this is just a little visual of Olin. I don't know if you guys can hear that, but they built a weeding robot and built an attachment, as you can see there, to support weeding in the field. Just wanted to give you a little bit of a visual of what it looks like as a student team building on top of the Amiga.
The Olin Agricultural Robotics Research Team.
And just to compound what Kelly said, we found that over the past couple of years, there's been quite a number of students who have started companies around the robotics challenge, who potentially have solutions that could be commercialized. And we really encourage that. You own your ideas, and we're super excited if you decide to turn your ideas into a commercialized product or a company. And so we're really trying to support that this year with their Innovation Award, with supporting cash prizes, mentorship opportunities for the winners, and just really excited to see what the next generation comes up with in terms of how to accelerate the restoration of the Earth's ecosystem and find new ways to support agriculture and food systems with robotics and tech. So thank you so much. And if you're interested in more about the Amiga, you can reach out to us, and we're happy to answer any questions that you have and any additional information on how to get a robot in the next couple of months. There's plenty of time for your school to receive a robot, to get a robot. And so we're happy to answer any additional questions and look forward to having you join us.
Awesome. Thanks so much, Leanne and Marcelo. So we are going to move over to Sean Hogan with IGIS to talk about the drone category. Sean, take it away.
Great. Just one moment. Let me bring up my screen. See which one it is. Here it is, I believe. There we go. And you see that fine? Is that coming through clear?
Yes, it's good.
Oh, there we go. Okay,
Yes.
good. So yes, as Kelly mentioned, this will be the first year that we're going to throw out this idea of a drone challenge to complement the robotics challenge, since there's a lot of overlap and interest here, of course. And wherein this is kind of a different approach than actually mechanically, say, weeding row crops or something to that effect. Usually drones are used for detection or remote sensing of areas that then can be used to answer questions that can to solve the problems that we're speaking of. That would include it always includes starting with identification of the problem at hand. This takes, of course, whatever agricultural knowledge is associated with the study sites that you might be looking at. But then when you follow through beyond that, then we have the technology selection, the data collection of the imagery, processing of the data, analysis, visualization, and then presenting the solutions in some kind of meaningful way. And I'm going to kind of just dive into each of these elements just to give an overview of what the steps to this would entail. The first step, of course, and this is not the most exciting of all of them, is just the complying with the safety and regulations. They do go in hand. So there's whenever you do some kind of drone operation, some of you, if any of you have done any kind of drone work, there's something called a Part 107 remote pilots test that is for non-recreational use. I'll get to that in just on the next slide, but that is something we can work around. You still have to register your drones. The second point, having a drone license is not a necessity in this case, but you do have to adhere to the rest of the drone related regulations. Like you need to be able to fly within Class G space. And in 1 second here, 1 second. There we go. And then you need to get authorizations if you're near a Class G airspace. No flying beyond line of sight. 400 feet is above ground level that you're allowed to fly to, and you can't fly over people. My slide deck is jammed. That's what I paused there for a second for. And I can't, there it goes. It finally advanced. I wonder what's going on there. Anyhow, so among these safety regulations, there is a great exemption though for higher education institutions where you can use this for education or research purposes. And this includes studies, academic research, and I believe that we would fall under this umbrella within the Ag Tech Challenge, fortunately. But you would still need to reach out to whoever your local, whatever your institution's environmental health and safety person might be. In our case, I'm that person for UCANR, but I know other institutions have other regulations for liability purposes, if not just safety too. I just wanted to throw that out there. So you still need to abide by the rules. The Part 107 applies. You can find out what those are easily enough online with a quick Google search or taking a trust certificate, which is often mandatory for even students to operate, at least within the UC system. Equipment. So here is the kind of the challenge for a lot of people is access to the equipment that you might need. This is something you'll have to find out depending on your given organization, if you have associated professors or some kind of drone groups in your area. The key element, and I'll get to this in a moment, is that for most scientific kind of level research with drones, you need something that can fly a waypoint mission, meaning an autonomous mission that's uploaded to your drone to be able to collect data in a systematic way. It isn't just flying the drone around just for fun with your like with the buttons on the controller. It's much more methodical. You launch the drone, it flies the mission as you programmed it. Then you get the kind of data that you need to be able to actually do some kind of meaningful analysis and visualization and so forth that we'll get to in a moment. I came from a background of remote sensing. I've been with UC-ANR within the informatics and GIS statewide program for a little more than 10 years. But before that, I worked in a remote sensing lab. And that's one of the reasons why I adhered to drone technology, especially when there was the confluence of this technology coming together here, the drones themselves, the regulations, and then the sensors. And the sensors are a big part of what gets me excited, but then the actual processing software that comes thereafter. So deciding what kind of camera you need, for like the simplest term, sometimes you call them imagers. You can have LiDAR units, multispectral cameras, all these and more. But there's generally, you can do a lot with just a simple RGB camera and get very valuable data. Before I talk about that, though, there's a couple things that you need to steps that must be taken when it comes to mission planning and data collection. And these are not all of them. You have to find out if you're in controlled airspace, because there's limits. In fact, a lot of drones will not even launch if you're in controlled airspace, say next to Sacramento's airport, or definitely most of the areas in Los Angeles. But you can find that information on something like Airspace Link, is a web app that the FAA recommends for finding out about controlled airspaces or temporary flight restrictions. And you can find out if your project's even feasible first looking there. The other things that you might need to do is check your weather. It's the thing with drones is you never know when how weather is going to work, and planning around that's always important. And then designing your missions given your project goals. I mentioned the waypoint missions, and there's a reason that we do that oftentimes is this. Oops, one more slide before I get to that. Oh, the other element you need is the software to be able to process this kind of data. Namely ArcGIS Pro and Drone to Map are two free. Well, they're not really free, but most universities provide them or have basically unlimited license that they can hand out to students. I mentioned this, the ArcGIS Pro, both from Esri. The first one, ArcGIS Pro that you're seeing here, that's for analysis and visualization. The Drone to Map is a free Esri product for image photogrammetry and stitching. And then that's what this is where this comes in. When you fly those missions, those autonomous waypoint missions will automatically collect images with a certain percentage of overlap, usually between 65 and 90. And based upon that information, a software package like Drone to Map can then auto-calculate key points between images. And this little diagram to the far right, it's giving a very simplistic perspective of what that calculations look like for the software to lock the images together and then do something called orthorectification, which pulls the images up into their vertical spatially correct positions based upon the telemetry logs of the drone. And then the products that you get out of that are nice high resolution orthomosaics. You can get vegetation indices depending on the spectral characteristics of your camera. Point clouds, so just think of that as like a cloud of points that make a model, digital surface models, and then textured meshes, which are essentially a point cloud draped or wrapped with orthomosaic imagery. So you get a number of interesting products from that allow you to answer a lot of interesting processing questions. Somehow this slide was meant to be a little bit later, or like that last slide was meant to be one up, and then the software package that we're going to like feed into this. But this is an image of ArcGIS Pro. This is where you do your analysis. And once you get when you can see in this background that you have three-dimensional perspectives of your crops, and the value of drone imagery is that it's very appropriate for plot scale research, where you can fly your mission at a small enough scale to get very fine resolution imagery. And then in some cases, you might compare that to another flight to see how things change. You can look for, say, issues with fertilizer, irrigation, pests, and then prescribe possible treatments for those sorts of things. And with that very neat 3-dimensional, or at least 2.5-dimensional imagery that you get out of that, you can do incredible visualization, which of course is powerful for being able to describe what is going on in the site. Here's an example of a study that I've done here in Davis, looking at pistachio orchards based on their genetics to see how different types or phenotypes of trees are growing, and then getting shape area, shape length meaning the perimeter of the tree, the canopy height for CHM is a canopy height model. NDVI is a normalized difference vegetation index, which you need a multispectral camera for, but that's a measurement of relative vigor or health of a plant, and then the other information. And then from this kind of data, this can inform much deeper studies of what is valuable for planting in one area or not. But what we have found in this project was that the effort of going out and flying a drone and collecting this imagery that I could process in a day and create a visual like this in a second day was incredibly more efficient than someone going out for a full month and collecting this data by hand and then turning it in and not having as good a visualization at the end of it. So I just kind of point this one out as a highlight of how you can report on your data, which is the last element of something like the drone challenge, would be to come up with some kind of imagery that was informative that you might be able to present on. It could also, as Kelly mentioned earlier, wrap this into like having a crossover with the actual robotics. Say if there was some form of robotic effort to add more pesticide or more fertigation in some given area, those two things could be tied together too. Although I know that those ground-based robots are fantastic at like almost real-time monitoring, classification, and say picking weeds or something to that effect. But this is a little different scale, and it can also be done above higher canopies that you might be able to do with a lower level robot in a field. And with that, those are the key things that I had to talk about today.
Excellent. Thank you, Sean. There was a question in the
Yes.
chat that I'm going to read for you because it's directly for you. It says, do you have any recommendations for open source or cheaper alternatives to ArcGIS? Our school is very small and does not have Esri licenses.
Okay. So in that case, yes, you can I'll start with GIS. QGIS is a fantastic package. It's a little clunkier than ArcGIS, and it doesn't integrate with other things as well. But QGIS, I used to use that back in the olden days. And then Open Drone Map is a relatively close to free software package that you can use. Those primarily are for RGB imagery. There's a little bit more of a learning curve for those, but they both would do what you need to do.
Great, thank you. I'm going to ask my colleague Lucy, who's been kind of tuned into the chat, see, did we miss any questions that came up? I know we've been trying to kind of respond in real time as we could. Or if anybody wants to chime in and ask their question for the group, now's kind of a good time to do that since we have 5 minutes left.
I don't believe we missed anything. But please, everybody speak up if you think we've missed anything and you've been politely waiting your turn. So, here I'm going to unspotlight Sean, and I will spotlight here Kelly, myself.
I see there's a question around the cost to a university that wants to enter the land challenge that needs to purchase the Amiga.
Yes.
The Amiga, the base Amiga is 13,000, and the brain is 7,000. So if you want both the base and the brain, it's about 21,000. And we can we can talk with you more about that. I put in the chat, the Nathan@farmng.com or education@farmng.com if you want more information. All the additional wraparound, the support, the documentation, all that is just, what we do in kind as support to the challenge.
Great, thanks, Leanne. We'll give people a couple minutes to kind of think about other questions, and I'll fill the space by saying, if you like what you've heard, you're motivated, you want to join the challenge, hop on our website. And I can already see there was one submission while we were talking, application on the participation tab. There's just an apply button, and it's just some basic info for you to submit to us that says that you're interested in competing. And if you want kind of more additional one-on-one attention, that's kind of how we'll start our outreach list. And I certainly make myself available, for calls or emails to communicate about kind of helping to get your team together. I'll say we are working on resources to kind of help support you. Simple things, flyers that you can use to maybe attract students or circulate around your university. All those things are going to be posted shortly in our resources tab. So that'll be available. I think some of the teams have, yes, you can add team members after December. It can be ongoing if you want to bring somebody, on in January, February, that's great. No problem there. Another thing that has come up in the past is fundraising. So I think there's a benefit to creating, having your team maybe be a student organization. I'm going to speak to Davis here because UC Davis, I've worked there for 12 years and worked with student groups. I know there's advantages in terms of applying for funding that the university has, or maybe the certain colleges for student teams. So think about that. Getting your team registered at the university could be advantageous to bring in some extra dollars. It's going to help with supplies. It's probably not going to buy a robot, but it'll help with supplies and some of the other activities that you're going to need to work on your project. And then I will also create a toolkit for fundraising that I'll post up on the website. Just include basic things so you don't have to recreate the wheel. A lot of, let's say, grants or fundraising pitches, they're going to need a summary of the event. And so we have all that language. We'll share it with you, the logos, pictures and documentation of what you're doing to kind of enhance that pitch. I know there's opportunities at different universities to join some of the giving days that they promote. And I think this is one of those projects that donors and alumni will kind of latch onto as being really cool and tangible, where there's clear impact that their gift is going to make. So that's something else that kind of, once we get our cohort together, we'll be communicating with you to kind of help support you through the whole process.
Kelly, I might mention, I was going to say too, I'll set up some office hours when the time comes. There needs to be help on the thrown in too.
Wonderful. Thanks, Sean. And yeah, we can circulate that amongst the community, and so you have a chance to tap Sean's expertise.
Answering the question about how other universities are purchasing the funding, are acquiring the funding. Many are led by professors who have funding in their labs, and so they use that funding to purchase the Amiga, and they're able to use it both for their own research as well as for for the challenge. Then there's other programs like one of the teams I think is through the university farm, and so as part of their budget, I think they purchased that, and so it helps them actually, operate the farm, but then run the challenge as well. And then I think some people have requested like special funding from their department heads for this.
Yeah. I also wanted to add that it's only a one-time purchase, right? So once you have the robot for your school, then you have it, and you have it for every, you know, additional and subsequent challenge moving forward. There's no recurring cost for participation.
Cool. We're kind of winding down. I do want to address this question though. It's in the chat. It says, can graduate students participate more than 50% if we're unable to find undergrads? So the reason we instituted kind of that rule or guideline is we do want to keep the playing field level as much as possible. So I would say really try and get 50% undergrads. They're around for sure. So, and I think it's a really valuable activity for them to be involved in, just in terms of their development and working alongside grad students to see, you know, how exciting, you know, going down the research path can be. So we're going to stick to that.
Yeah, and just
and again, oh, I was going to say again, they don't have to be engineers necessarily, and so, you know, go out to your ag schools, go out to business schools, because there's different ways that different students can add value to the team.
And we just also wanted to say that one thing we didn't touch on was just what a great recruitment tool this has been also for FarmNG and for other people in the industry, in the ag and the tech space. We found that the students who participate in this challenge are super passionate about this space, and that makes them really exciting to us and people in the industry as potential hires. And so just another piece of the challenge that's been really powerful for both the students and for us as industry participants.
Many of the students, well, there have been several hires out of the challenge, a few patents filed, and
companies.
Sorry, more good stuff.
Can I
So
just add
one
one
last
thing,
question.
or can I just get something really
Oh, sure.
quick for clarification to make sure we get people? It looks like the application form, if I have this my understanding correctly, you don't need to have a team formed yet. Any individual can go who's interested should go ahead and fill that out. Is that correct? Whether it's advisor or student?
Yeah, if you intend to compete, you're really serious, you want to connect with us one-on-one, send that in so that we can get you on the radar and communicate with you. And you know, some folks need additional help in recruiting team members, and we could provide those resources. So yeah, if you're motivated, you want to compete, get the application form in. One question here, we're just going to go over a minute just to address everything. Can it be a mix of students and working professionals? I would say your working professionals really need to be mentors, not kind of the core unit of the team that's working on the project. You know, this is a college level competition, so we want to keep it that way. There you go. And Lucy just replied to it. Well, in closing, this session has been recorded. It will post it up on the website. I'm going to send a follow-up email to everybody that registered so they have access to it. It's just a starting point to get the wheels turning for this year. I want to thank everybody for tuning in, for listening. I want to thank FarmNG, IGIS, and Lucy for being on the webinar today. I think it was really productive. And I will just close by saying that prior to this webinar, I had about 5 or 6 different universities already submit an application form. So I've heard from University of Illinois, Urbana-Champaign, Purdue, Olin, Mississippi State, UC Merced, and Lemoore Community College, which is great. So I think we're going to have a really great cohort this year, and we're excited if you come on board and participate. So thank you again for tuning in, and we'll be in touch.